Welcome back, everybody. Mr. Sean here from your Activity Tutor JA. Let's get back into it, right? So in the previous video, we talked about subsets, right? And those are sets that their elements can be found in another set, right? So let's kind of build on it today. We're going to jump into a past paper. Which past paper is this, people? 2017, all right? So let's kind of just see if we can just talk through this guy. All right. Now, there's a couple things I'm going to mention. All right. This guy, the universal set, is defined as the follows. Now, I don't think did I describe what a universal set is? I don't think I did. So the universal set is kind of like saying, for this question, we're only talking about the numbers or the members that the universal set is set up to take in. All right. Now, let me give you an example. I can have a universal set that says, well, we're only going to take numbers from 1 to 6. Okay. But then they're going to define other sets, like say set A. And I'm going to say set A is even numbers. That's all I'm going to say, even numbers. But now I want you to understand what is happening here. It's not just all the even numbers in the entire world, you know. It's not 2, 3, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, blah, 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 blah. This is really saying I want the even numbers that can be found in the universal set. So then this is the definition in words of set A. So then what would be the set in terms of its members? Well, I'm going to look in my universal set and I'm going to apply that condition. Are you even? No. Are you even? Yes. So he's a member. Are you even? No. Are you even? Yes. And you keep on going. And the last one will be 6. So then I can say set A, he's a subset of the universal set because all of his members came from the universal set. That makes sense, don't? All right. Then we're going to define another set now. We're going to call it set B. And we're going to call them the prime numbers. Once again, everybody, when I describe him as the prime numbers, you have to remember we're only restricted to the values that can be found in the universal set. So again, I'm going to kind of apply this condition to everybody. Are you prime? No. Are you prime? Yes. Check the other video for if it's prime or not. Prime numbers only have factors of 1 and itself. Only 1 and itself can divide into it and don't give no remainder. Are you prime? Yes. Are you prime? No. In fact, let me use a red. We just say no, no. And then 5, is it prime? Yes, it is. Are you prime number 6? No. So the numbers are primes. So B would have 2, 3, and 5. Yeah. Now, one thing we're going to talk about today is the visualizations. All right. And my student is texting me, so sorry. Let me talk to them after this video. Now, let's make sure we understand what's happening here, right? So when it comes on to this universal set, and then we have 2 sets there. Now they're going to ask you to draw a Venn diagram, people, and there's a lot of marks to it. So the first thing to make sure you understand, a Venn diagram is just a representation of what you have out here. So first thing you're going to realize, I'm going to define my universal set. I'm going to pick a big U out there. Okay? He has 6 values that I must find in him. Now, one thing to appreciate here now, let's make sure we understand. There's 2 other sets. There's a set A, right? And he has some members in him, right? And there's a set B. He also has some members in him, right? And so we're going to kind of start to appreciate what's happening there. There we go. That now we're going to have 2 sets that can be found in the universal set, okay? Now, in set A, I'm going to put the elements that can be found there, 2, 4, and 6. For B, I'm going to draw the elements and put the elements in there, 2, 3, and 5. But then there's a couple things I notice. Do you notice it with me? There's some elements that I find in A that I also find in B. You notice that? So why would I write it twice if it can be found in both, right? So I'm going to redraw this. So I'm going to erase this, and I'm going to erase this, all right? So I'm going to kind of redraw. So for set B, I'm going to make them overlap because there's somebody that can be found in set A and in set B. He is the number 2, right? So bear in mind, set A is this red line. So everything in that red line belongs to set A. But then set B is this green line. So everything that can be found in that green line can be found in set B. So if you notice 2 can be found in A and in B, right? Then I go again now and I say, well, 4 is in A, he's not in B. So I put him here. You notice that this is the section, right? So the shaded part, that's just A. It's actually described as A only. You can only find him in A, right? Then I'm going to put down 6. You can once again only find him in A. Then over here, I'm going to put 3 and 5 because I can only find it in B, right? So that's called the onlys. So when I describe here, you're going to notice I describe it as A only and B only. That makes sense? Hope it does, all right? So let's kind of go through. But there's something about my drawing that's incomplete, everybody. What's incomplete about it? All the numbers that are found in the universal set, are all of them in here? I see 2, okay. I see 3, okay. I see 4, okay. I see 5, okay. I see 6, but me not see the number 1, yeah? So then that means, is number 1, can you find number 1 in A? No. Can you find number 1 in B? No. So he would not be in any of these bubbles. He won't be in the red bubble or the green bubble. So he's outside. Because every of those elements in the universal set must be able to be found in the big U. And that is the Venn diagram that they want you to draw. Right? 5 marks, 10 marks, we don't know how much marks they may give you, but make sure you understand what's happening here. So when you find that two sets, you can find the elements. There's a similar element that is in both. That's because that element can be found in both. You're going to make the bubble overlap each other. All right? So let's get back to the question now. So there's a set M and R are subsets of U. Okay. So that means that U is the big guy. And then there's a M. And then there is a R. Many of them overlap yet, So I'm going to draw it like that first. Then I'm going to figure out, do they overlap? Okay? Now, this is a very complicated definition that they have given us. So let's kind of make sure we make sense of it. All right? Now, what this is saying in words, I know that X are the values. They come from N that's called natural numbers. Everybody write it down. Natural numbers, all right? I think I'm going to do a video on the different types of numbers: natural, whole, integer, real, not real, if it's possible real. All of those we're going to make a video on, right? But for right now, I want you to take natural numbers as they are counting numbers from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to infinity. Natural numbers don't include 0. Natural numbers don't have no decimals. So it's just literally the counting number. 1, 2, 3, 4, blah, 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 blah. So write it down. Natural numbers are numbers from 1 and it keeps on going forever. Yeah? Now, this universal set says that all of its elements come from the natural number. Okay, good. But then it puts a restriction on it, people. It said the values of it is between 12 and 2, right? So then now you got to realize, what's the universal set then, people? What are the numbers that they're referring to? It have to be in the natural bucket, but it must be between 2 and 12. What are the numbers between 2 and 12? 3, 4, 5, 6, 7, 8, 9, 10, and 11. I'm not going to include 12 because I need to be between 2 and 12. Not including 12 and not including 2. Okay? Numbers between it. right? And are all of these a part of the natural bucket? Yes, they're all counting numbers. So that's the two conditions that you must do in order to figure out your universal set, all right? Then it says, list the members of set M now. So it says set M are the odd numbers that you can find in that universal set. So I'm going to go through, I'm going to say, wait, you odd. Yes, 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 you odd. So set M, we have 3, 5, 7, 9, 11. You're done. Because we know, remember, these sets right here, their elements are coming from the universal guy. Then we go ahead and we'll say they're the square numbers. I don't know what square numbers mean, you know. I'm not going to lie to you. But I'm thinking they're referring to numbers that are coming from you squaring a number. So I said to myself, what's 1 squared? 1. 1 times 1 gives me 1. Right? That's not found in the universal set, so I won't put in there. Right? Then I go to 2 squared. That's 2 times 2. This exponent tells you how much time the base is going to repeat. So it's going to repeat twice, filling, multiplying between it. So that's 4. Did I find 4 in the universal set? Yes. So I'm going to put 4 there. Right? Then we go again now. The next number after 2 is 3. So 3 squared. That's 3 times 3. What am I doing here? This is telling you how much time the base is going to repeat. It repeats twice. Put in multiply. So 3 times 3, 9. So 9 is there. Right? Then we go to 4. What's 4 squared? 4 squared is 16. 4 times 4 is 16. I can't find them in the universal set, so I stop. So I now know who are in set R. Set R have 4 and 9. That makes sense? Yeah. So what we appreciate is how to deconstruct the stuff that they're giving you. Then we'll say, okay, well, miss your 4-mark question here, sir. They said draw a diagram to represent this entire thing. So I'm going to say, okay, draw the box, draw your U. What were the 2 sets that they called it? M and R. So M and R. You notice I'm going to draw it and them overlapping. Why did I do that? Why did I do that before? Because there was something that can be found in both of them. So there's an intersection. So then we'll say, all right, wait. I notice that 9 can be found in both of them. So then that means that 9 is going to go right here. So then we put M here and R. What's going to be the elements left in M? We already have 9 in there now. So we're going to say, okay, what's left? Let's go to it. So we have 3, 5, 7, and 11. So we'll put 3, 5, 7, and 11. Then what else is left in R? R only have 4 left in there. So I'm going to put 4 over here. Right? Then I ask the key question here, everybody. What was the universal set? It was all the numbers from between 2 and 12. So 3, 4, 5, 6, 7, 8, 9, 10, 11. I see 3. I see 4. I see 5. I don't see 6. So then that means 6 out here. I see 7. I don't see 8. So 8 must be out here. I see 9. I don't see 10. So 10 must be out here. So you have to make sure that all of the numbers of the universal set are still in the entire diagram. That makes sense? These are just the elements that don't belong to the M and the R. So you have to make sure you put them there. 4 marks, get your 4 marks. Later. See me next for set visualization. All right?